2 decades of experience in teaching and research with expertise in structural engineering, concrete technology, computational techniques, and the application of artificial intelligence and machine learning in civil engineering systems. In recognition of his outstanding academic and professional contributions, Dr. Palanisamy has received several prestigious awards, including Vishwakarma Award 2018, conferred by Construction Industry Development Council under Planning Commission of India, the Outstanding Young Concrete Engineer Award from the Indian Concrete Institute, and the Dr. A. APJ Abdul Kalam Gold Medal Award for Engineering Education. He has also been honored with Sri P.K. Das Memorial Best Faculty Award along with other national level recognitions for excellence in education and research. Dr. Palanisamy has published extensively in reputed journals, guided numerous undergraduate and postgraduate projects, and continues to actively contribute to research, consultancy, and professional development initiatives. We are truly honored to have him with us today. On behalf of Department of Civil Engineering and Institution Innovation Council SVCE, I warmly welcome Dr. T. Palanisamy to the webinar. Welcome, sir.
Yeah, over to you, sir.
Yeah, thank you very much. My screen visible?
Yes, sir. Visible, sir.
Yes, sir.
Moving slider?
Yes, sir. Moving, sir.
I can start now.
Yes, sir.
Yeah, fine. Good morning to all. So my sincere thanks and appreciation and gratitude to Department of Civil Engineering, the Institution Innovation Council, then Sri Venkateswara College of Engineering, Chennai, and Professor Kumuta, and the senior professors and the coordinators of this program. Good morning to all, and my dear students and friends joining me online. So today I'm going to talk about the AI applications in civil engineering. In particular, prediction of strength of building components using machine learning technique. So in this era, every places, every forum, each and every classroom itself, they are talking about that AI, artificial intelligence. It's entered all the field, knowingly, unknowingly. So he is not given the chance to us to enter much more in that field of civil engineering. We are rigid about that civil engineering, but without AI, nowadays we cannot solve any kind of problem, that kind of forces behind us. So we want to learn about, sir, what is that AI? So how to develop one kind of model using the AI. Nowadays, lot of AI tool is available. For example, calculation of multiplication, kind of, and the small programs are available in AI. But as engineering, what we want to do, it means how we can develop that kind of small programs for our applications. That is important. For example, you take that mostly we are BTech students just right now. Mostly in case of Word, we have one kind of function or some kind of tab. Directly we can click and we can use that particular tab or function for our solving our engineering problems, even type for some documents and so on, so things. So we are not talking about that. So how we can develop that kind of function, that is we are discussing today. Now, where is application? It's a more we need AI application means, for example, multiply by 2 into 2, no need of AI. or anything. Simply with memory, we can calculate what is a 2 into 2 equal to 4. For when you need that, when you rendering the help of AI means, the problem is very complicated, very difficult to analysis, or very difficult to handle the problem. We are running behind with that AI. And in the AI itself have a lot of subdivisions, the how we can use this AI's applications in different field, not only civil engineering, other field also we can use. So I will give general introduction about that. What is AI applications in civil engineering? Basically, I want to say my sincere thanks to my research group. These are my research group. I sincere thanks to this PPT, to Shreyas A and Siddhi Vilasini, Stuti and Swapnil B. These are all the members is behind of me helping this presentation. Basically, before that, I take 5 to 10 minutes regarding civil engineering. Then after that, I link this matter to this AI. In particular, the beam, you know that so in the building system, we have the beam column joint. The beam column joints looks like this. Interior, exterior, corner, roof interior, roof exterior, roof corner, so on so, etc. So you may be asked why I want to insist beam column joint here. For example, take this building. Take this building. You look at this figure A, B, C, D, and all. For example, you can take this figure. This figure, right? The beam is good enough. Column is good. Column also good. Beam is good. But in this junction, it's have some kind of problem. Can see here, and see here also. In this building, column it's good. See, like this. So here, this is the some failure photograph. Now, what is that problem here means? I'm ready to do any kind of design to the beam column joint. So where it is the problem means lack of availability of numerical methods and depth treatment in the standard text. Still, we have the lack to calculate the what is the joint shear strength of the beam column joint. Still, is not available. Why? Because, for example, you can take the simply supported beam. Easily, you can calculate what is the bending moment, what is the shear force of the simply supported beam. Even you go for any kind of fixed beam, cantilever beam and all, even continuous beam also, up to 2 to 3 span you can calculate easily. Again, the span is increases 2, 3, 4, 5 a number of span, and the load combination is different, geometry is different, very difficult to analysis design the number. Similarly, here also, you take some beam column joint, they have the huge number of forces in the beam column joint, very difficult to solve using single formula. For example, this is the column, this is the beam, we have the huge number of forces. For example, shear, then horizontal shear, vertical shear, the moment, then tension, then compression, lot of forces involved. So in the simple method, you cannot calculate all these matters. Either you go for that numerical analysis or you go to that some experimental analysis, you can find that what is the behavior of the structure. Both are very complicated, and numerical method is somewhat it's okay, but in case of experimental methods, we spend the more money to find what is the behavior of the structure. So here, this is the behavior of the beam column joint. in an earthquake. So it looks like the beam column joint subjected to tension as well as compression also. For example, this is a standard one. So during this earthquake, it became like this, it's bent like this. So what is the things means? The beam column is subjected to compression, tension, even bending also. So these particular portion have the problem. So we want to solve the problem. So I because means the joint is very rigid, more sagging moment inside. These are all the things. Maybe finally students may be aware about that. Column strength is greater than the beam strength. Okay, that is called as weak beam, strong column concepts while you're using. Then our concept is the joint strength it should be greater than the column strength. So that is that weak column, strong joint concept. Here weak beam, strong column. Then weak column, joint strength. What is that philosophy is strongest joint, strong column, weak beam design. This are all ready. So what is the problem means? We want to know what is the problem means lack of availability of data, how the structure is performed with respect to the earthquake, in particularly beam column joint. So for that, what we trying to do it means we can make the model or otherwise with the fast experience we can learn something, then predict the future. So these are the some forces acting on the system, so tension, compression, so on, so etc. These are the force anatomy of that beam column joint. So you may be asked, sir, already some formula is available. Through this formula, we can calculate the column shear, joint shear, so on, so etc. Yes, the some formula is available. What is the problem of that existing formula means? So they have the limitations of that formula. For example, you take that one kind of simply supported beam. For example, like this, simply supported beam like this. Length is L. The load acting, the member is equal to W per meter run. So what is that bending moment? Kilonewton per meter. What is the bending moment? W L square by 8. For in case of the bending moment, it's a bending of this beam not only with respect to that length and W, the weight, right? It's maybe depends upon that cross section of the column also, with respect of the depth, respective of the breadth, what is that? Density of the material, right? Temperature, right? Again, the shape, not only is a rectangle, in some place it's maybe looks like kind of irregular in shape, or sometimes it may be T shape, or so on, so etc. So generally we can take this formula W L square by 8. So as in that field, it's not exactly depending upon the W and the L. So many number of factors involved. So as our calculation purpose, as for simplification purpose, as for the assumption, we are ignored all these parameters. All these parameters, simply we calculated WL square by 8. It's my concern is the already existing formula, like this kind of formula. So it depends on 1, 2, 3, 4, 5, 6 variables only. So we predict that interior exterior corner beam column joint shear strength by 6 parameters only. So it may be more than that 6 parameters involving the behavior of the structure that we are missing. Now, what is that need of machine learning, deep learning, and all those things means? Here, the problem is very complicated in nature. The more number of variable involved in that system, which one is influencing the particular parameter, this is very difficult to categorize and take out from the system to do the analysis. For that, we are entering the machine learning concepts. Then this is a computer science, data science, AI, machine learning, and deep learning. For example, so how I can easily teach with you or how to understanding the machine learning concept means. For example, computer can say you give the input. For example, input means multiply 2 into 2 equal to 4. So this is my objectives. So I can type 2, I put that operator again at 2, put equal, I can get the answer. So here, if the computer its take or calculator its take 2 means 2 only, he doesn't know what is the physical meaning of 2. Only 2 only, it's maybe man or maybe tree or maybe donkey or monkey, whatever it may be. The calculator doesn't know what is the representation of 2. So what I did, the multiply, I give the answer. That is that computers and calculators doing like that. Now, what is that meaning of machine learning here means? For example, I'll take 2%, person 1, for example, P1. Another person, I will take P2, P1 and P2. So I categorized what are the characteristics of P1. I categorize what is the characteristics of person P2. For example, I can take some kind of some properties. For example, height, H1, weight, W1. Okay, then height, weight, then fitness, right? Walking, so on, so etc. I can take up to n parameters. Similarly, P2 also H2, W2, F2, so on, so etc. So, what are the relationship between person 1 height and person 2 height? This is person 1 height. And how does the person 1 height influence to person 2 weight? Similarly, I can develop lot of establishment with respect to different variable for f, this kind of. So after that, finally, I can get some kind of information from this. So that is called as, we'll give that data, we give that data to the system. That is it, input data. So after this giving the data, the system or computer, it may be analysis what is the relationship between these parameters. It's learn. Okay, how it's learn means from the past. For example, you have that some idea today's maybe T20 matches there, no, right, under junior, that matches you maybe come to the conclusion today that match will be win or lose by India. For example, only I'm telling, right? How we can predict means we can predict with respect to the fast data. Correct, no? So when the match was happened the last year, who are all the players, how much run was the taken, and what is the nature of the pitch, that time it was rainy or not. Similarly, not only 1 year data, you can take 5 to 10 years data. From this you maybe learn this match may be win by that particular team, India team, or whatever it may be. So what you learn, this kind means from the previous experience, the previous incidents, you can predict the what is the future. Similarly, these concepts may be applicable in other field also. For example, I want to know about that what are the good products is coming out from the industry. For example, you can own medicine drug industry, right? They're producing the huge quantity of medicines, drugs for the medical applications. Then every time we cannot enter and check this, all these medicines or drugs. Very difficult. For that, you maybe develop one kind of machine learning algorithm. If you fix on sensor, the sensor maybe capture the images it's getting down from that particular machine. It will check whether this is correct or not. It finds some kind of defects. It may be stored in the system, and good things also stored in the system. Now you develop one kind of learning model. If good things it's stored in the system and bad things also stored in the system, now it compare what are the goods, what are the bad with respect to the good or bad, vice versa. Come to the conclusion, what is that level of good or bad at present. Similarly, so what do you think means learn from learner from the features. For example, in the villages and all, you know that elders always follow that youngers. For example, we have that grandpa, grandmother and all. My father and all, they're following my grandfather, granddaughter, grandfather, grandmother's way. I'm also following my father's way. So how we learn means what are the things, good things or bad things? It's learned from the experience. Similarly, here also we have a lot of data available with us regarding that beam column joint. I taken that data. From that, I can develop one model or predict that may be my what the future applications. Here, two concept is there. One is deep learning, another is machine learning. So still we have a lot of debates is going on deep learning and machine learning kind of. It's my knowledge I will tell you. For example, I can predict the beam column joint with respect to joint shear strength. Joint shear strength possibility is there. That is one way. I can find what is the joint shear strength using the standard formula. I can tell it's maybe good or bad. Other one thinks through that visual observation or through this photograph or through the failure mode. Failure means how it fails, where it is a cracks, right? Its cracks is vertical or horizontal, multiple crack, simple crack or single crack, surface crack, inside crack, so many things is there. With respect to the failure, I can come to the know the what is that capacity of my particular joint. That is called as image based, right? So first one is this is data based. Second one is image based. Image based. With respect to the image, I can find it's maybe good or bad. For example, this application, for example, image based application, that is called as the deep learning concepts. So while using in that classification of that particular objects. Classification means what? I can have 1,000 number of beam column joints with the photographs. Okay, no, I can have 1,000 number of images. From this image, I want to detect or find which of the images it's irrelevant to the this one. For how I can find means you train the computer, you train the system. So what are the things is good, what are the things is bad. So the machine it's learn and give the results. It's maybe good or bad. So how that machine it works with respect to images, with respect to images. And one more thing is with respect to the calculation. If the my shear stresses from this range to this range is good, from this range to this range is bad. So with respect to the numerical data, I come to conclusion this is bad or good, or maybe accept or reject the particular things. So what we are doing, one of my research scholars, two research scholars doing this area, Siddhi Vilasani and Sakshi, both are doing that hybrid approach. Sometimes you can go for that statistics based or data based. Sometimes we can go image based. For example, civil engineering, that's good, no? So we can predict the what is the load carrying capacity of my member using calculation. Similarly, I can identify or I can find this member, it's maybe failure by shear or failure by means of um, bending, torsional, or combined all those things. So we have the very good opportunity. We can deal in the data as well as images. Fine. No? So we are developing hybrid algorithm. How predictions be happening in that beam column joint. So now little bit it's okay, fine. Machine learning means data based, deep learning means image based. So the approach is different. Both approaches are different. For example, these two machine learning and the deep learning concepts highly depending upon the data. For example, you can see this PPT also. In case of the computer, no need input only. Command it will do action. But here data. Data means not a one matter, right? The lot of things is there. Data means the variety is something different. For example, data, for example, you take that the shear strength of the beam column joint. The data is varying from 0 to infinity also possible, right? So this model, entire model, learning things is depending upon the input data. Input data. Under learning also important. For example, the same problem give on small children, right? Small children, the taking the problem is different, but the same children's become as engineering college, he is solving the problem is different way, under learning also different way. For example, I can say we know that we take that some kind of water bottle, right? So when we know this is a water bottle exactly, maybe age 1 couldn't, age 1.5 no, age 2 somewhat we knows it's maybe water bottle or milk bottle or some kind of bottle. Then third and fourth, we know that this is the bottle carrying the water, the shape, everything, we know that. After that, you come to the join this engineering college, you thinking your put mind how it's manufactured, what is the shape of the bottle, how they made the bottle, right? How to pour the water inside, how to fix the cap on that water table. Lot of things you're learning, correct? No? So depending upon your experience, the rate of learning and the quality of learning will be changes. For example, myself, the childhood is different. My teenage, my characters is different. My this is another father is just different. If I become as a grandfather, my characters will be changes, and the learning also changes. So what is the things, important things you want to note down here means the output, it's a depending upon that learning, what we're learning, what we understand, that is important, and input data. For example, one person, it may be living in that very bad situation, and he learn all the bad characteristics and bad things, it became as a bad. So most probably like this only. So what are the input and learning and output? So we want to concentrate on learning time. Other one is the input data. So here, what are the data available? How we can refine the data? That is very important. This already you studied these kind of graphs in your BTech itself. For example, I can take the first graph. I want to establish what is the relationship between data in x direction and y direction. For example, x I can take one data, y I taken take any kind of data. I want to establish what is the relationship between these two. I can represent these things by means of one straight line. Represent the straight line represent all the data. For example, you take these particular data, it's a highly deviate from the average. So this data, it's not up to influence the system. For example, these two data is also same. For example, this data also. This is so far away from that particular region. This and all not contributing much. For example, these data is also, for example, up to this also, these data not highly contribute to the system. For example, up to this also, it's so much deviating from the system. Correct now? So now what I'm trying to do, it means what are the effective datas available within the range I will take. Within the range, this particular range only, I will take the data. These are my point of view. This is good. So what are the things means like a Anna Pravai, right now? So it take only the milk from the water, then it's leave the water as it is. Similarly, what are the good data available? That only I will take. Rest of things I will omit it. That is called as refinement of data. That is called as refinement of data. Any machine learning concepts, first you do the data collection, then refinement of data. So how to collect the data? How to collect the data? So any scientific procedures available or not? So you may be develop any kind of model. You only design what kind of data I want to take it. So for example, I want to calculate beam column joint characteristics. For example, like this. This is the beam column joint. You can assume. Assume only. So I want to know what is the strength of the particular joint. What are the point? What are the things? What are the datas I can take for my model? As per your knowledge, what are the parameters contributing that particular joint? For example, I can say one is the concrete. Inside we have the steel. Then what is the quality of the steel? What is the grade of steel? Concrete, steel. These two important. Next one is depth. Correct, no? Depth. Then cross section of the column. Cross section of the column. Right? Then percentage of reinforcement, percentage of reinforcement of the column, percentage of reinforcement in the beam, then grade of concrete, grade of steel. Similarly, I can take so many parameters. Now you can develop or establish what is the relationship this parameter, like this kind of curve, which are the parameters away from this, you can remove it, you can proceed, you have that some data refinement will be happen. For example, you can take the grade of concrete, grade of concrete. So nowadays, the grade of concrete, minimum grade of concrete, M20 grade concrete using in that field. So suppose you consider grade of concrete, you can fix the range from M20 to what is the maximum grade of concrete in the field up to M60 I can take. Suppose I want to do any beam column joints, I'll fix my grade of concrete from M20 grade to M30 grade concrete only, like this. So now you refine the model, no? Refine the model. Then, for example, I go for the steel. Steel means I will take the range of the steel 415 Newton per mm square or Fe 415 steel to Fe 500 steel only. To Fe 500 steel only, for example only. Now, breadth of the section I will constrain. Right, breadth of the section I will take only the 230 mm, not a 230 mm or 250 mm. For example, I can take 200 mm to 230 mm or 250 mm I can take. So similarly, you refine the data, then very good data, it will come, you fix the range, you take the particular data, unwanted thing should be taken. Now, here, some terminologies to understand the artificial neural network. One is that labeled data. Labeled data, it means that what kind of inputs are given and what expected data should be output. So you know that what is the input, what is expected output, right? And not in any random value or number to be given as input or without specifying it. So you know that input and output, that is called as a labeled data. For example, M20 grade concrete. I know that. What is the grade of concrete? What is the things? Then this algorithm, hyperparameters, which are highly influenced and all. You know that what is a machine learning categories means? One is supervised learning, one is unsupervised learning, reinforcement learning. I will take 1 or 2 minutes what kind of learning you may be take for the civil engineering problem. What is a supervised learning? The supervised learning is a method in which we teach the machine using the labeled data. We know that labeled data. So what is the labeled data? You know that input and output. For example, I come to the beam column joint. I know that what is the joint shear strength. I know the shear strength of the joint, right? Then this is called as a supervised learning. For example, that is in your classroom teaching, it's under the control of supervised learning. For the label, what is the label of SVC, Sri Venkateswara Engineering College, on the banner of Anna University? So you are studying that, you're getting the degree. That is called labeled degree, you get it. Finally, you got the degree with the label. This is called as a supervised learning. Unsupervised learning, the machines trained on the unlabeled data without any guidance. For example, this forum now I am taking the class, you are seeing through that your mobile or laptop. So I am sitting somewhere, you are sitting somewhere, we are learning. I enable to see your face. You may be understand or not, you taking or not, you are learning or not. or it may be open your iPad or that is your laptop, or you mute event other some sites. So this is I'm not controlled anything with respect to unlabeled data. I don't know how many students are learning this lecture. What is your name? What is your register number, roll number, so on, so etc. If I am same person, I am taking the class. Finally I'll take the attendance. Who are all attending my class, right? Who are learning my class. I can take what is the output kind of. So that is called as supervised learning. This is unsupervised learning. Another one is the reinforcement learning. This is very interesting point. This is very interesting point. Like a tutorial class in your mathematics. For example, professors give some kind of problem. F of x is equal to some kind of things we can solve. This kind of. Then you maybe solve some kind of step with respect to the previous classes and so on. So things. Some place you may be stuck. Some place you may be stuck. How to solve this kind of problem? That time you may be rent the help from your friends or any teachers. They will help you. So whenever you have some kind of deviations in this problem, you can, that is called as reinforcement learning. For example, I design any kind of structure. You can design any kind of structure. For example, I can take one beam, simply supported beam. I want to design for the external load. Correct? No? I'll proceed these things. I can assume the depth of the section, for example, only 100 mm. My load is around 30 kilonewton per meter. 30 kilonewton per meter. I'll proceed my design. I calculate what is the moment. Then I can calculate what is the AST, so on so kind of. Finally, how to conclude the design? You know that what is that AST. After that, I provide some AST. Then I will check shear, torsion, deflection, then so on so things some check. If my design it's okay for moment, but failure in the shear, I redo the design. Okay, now if bending okay, shear it's okay, but deflection is the problem means I redo the design. So in this kind of problem, you can take reinforced learning. You can take reinforced learning. Now, when I will take the supervised learning, means I know that what is that input and output. For example, I know that I want to calculate what is the bending moment of this particular beam. Bending moment of the beam I know is W L square by 8. I know this. Correct now. So I can add some other parameters. So what is that bending moment? It may be changes or may not be changes. That is we called as supervised learning. Or otherwise unsupervised learning, I can give one more example also. Unsupervised learning. For example, the water is flowing on the river. For example, this is take it as a river like this from Metru Dam to that Tanjore up to the Bay of Bengal. Its water is flowing. Now I know that how much water may be discharged from this point of A. Then how much water it may be reach in that C, Q, B. I cannot exactly predict. That is called as unsupervised learning. Unsupervised learning. For example, in case of structural problem, calculation, analysis, I can go for that supervised learning. The design problem, I want to design. I want to make it a track. That particular things now. I am using the reinforced learning. Then unsupervised learning, for example, the structural flowing of water in the stream, flowing the water in that canal. And one more very interesting example is we can predict the what is the flow movement of cloud, movement of where it goes to cloud. So that is under unsupervised learning. For example, the flight movement tracking, that is called supervised learning. I know that what is the destinations. I will start from India. I want to reach the Chicago. So I go like this. I know that what is the track everything. So I know that what is the starting point, what is the end point. I know that. Correct? No. So the reinforced learning, you can use the transport problem also. I want to design some kind of signals. I want to design some kind of signals. You can use reinforced learning. So these are the some basic fundamentals and the concepts of machine learning application in civil engineering. Now, what are the model we can take? How to predict my learning is correct or not? That is important. One is the data. What are the data is given to the model is important, and how this learn my computers is very important. And if I can get some output, my learning is correct or not, my prediction are correct or not, how I can calculate using some kind of output. For example, linear regression analysis, kind of we can do it. Now, other important things is AN, that is nothing but artificial neural network. This is one kind of network we can use to solve the complicated problems. It works like our neurons present inside this. Then first you can go for any kind of machine learning or deep learning, artificial intelligence kind of means that data is very important. That is called as database, for experimental database. With respect to the database only, it will work. You give the good data, you can get the good results. You give the bad data, you can get the bad results. That kind of, right? So now, how to give the good data or bad data? How I can classify that data? It's maybe how the data it's maybe classified good or bad, so on so kind of things. For this, before that, unwanted things should be removed. For example, this is a particular beam column joint. What are the things I taken means only I consider exterior beam column joint. The specimens will eccentricity between the beams and column is avoided. So these are some anomalies. So you can remove it. Your database will be pure. And the final failure modes will be joint shear failure only. So similarly, I taken so many parameters. For example, I can take here. So what are the parameters taken for the beam column joint for this particular analysis means here one is the width of the joint, then joint depth, the compression strength of the concrete, beam reinforcement, length of the beam, yield strength of the beam, then joint shear reinforcement, column axial load level, beam bar, beam column, so on so etc. Around 11 parameters I consider for this analysis. So for example, what is the drawback of other formulae? Why we developing this means, for example, ACA, I can have around 1, 2, 3, 4 parameters only. In case of European code, I have 1, 2, 3, 4, 5 parameters, right? Then IS Indian code 1392020116, 1, 2, 3. 3 parameter only. The New Zealand code and all 1, 2, 3 parameters. What I'm trying to telling here means I give any kind of formula, it's involving more number of parameter, more number of relevant parameter, it gives the exact results. Otherwise, it's give the more conservative results. It's not exactly it's applicable in the field. What my intention is, I introduced so many parameters, and with respect to that, I developed a new formula. That formula is maybe useful to predict the joint shear strength. So why I put this means, for in case of compressive strength, FC means labeled data. TST labeled. I know that what is the input and output down from this particular data. So these are the some mathematical model, how to model it, how to enter in the system. This table is very, very important table. So you may be take any kind of projects in case of machine learning or deep learning kind of, the statistics of the data is very, very important. I already told you know that. So for example, I can take compressive strength of the concrete is the third one here. Compressive strength of the concrete, FC. I will take the maximum of value of X is 96, the minimum of 15. So I can take that more number of data, even I can calculate the 1000 data also in the particular beam column joint. The joint have the compressive strength as the minimum of 15 Newton per mm square and maximum 96 Newton per mm square. Similarly, I'll refine my model, I'll fix the range of the maximum, minimum, and these things. From this, I can calculate what is the mean, what is the standard deviation. It's all the data, it's all the more deviation from the mean means you should do omit and remove the data. What are the good data available? That only day. This only that refinement of the data with respect to the standard deviation. Similarly, you have a lot of other mathematical model to refine the data. Nowadays, some advanced machine learning, AI tool available in the online itself. We can use these kind of functions, mean, turn in these kind of functions. We can refine the data very nicely. Now, after this, we want to develop the model. How to develop the model means we want to train our model, this kind of. So here we are talking about the neural network, artificial neural network. It looks like our neurons working in our brain. So how we know that this is maybe water bottle, this is computer kind of. The neuron give the signals, so and compare with previous memory and all those things, it will gives this is maybe bottle kind of. Similarly, in the system also, I have the so many parameters x1, x2, x3 up to xn. For example, height of the joint, width of the joint, depth of the joint, so on so, etc. I can assign some kind of weight W1, W2, W3. For example, some parameters highly influence the particular function f of x. Some parameter, it's not highly influence the particular parameter. For example, I can take grade of concrete, it's highly influence the strength of the joint. Again, the temperature of the beam column joint, it's not much contribute the beam column joint. So, for example, I want to assign what is the weight of the particular parameter. If it is highly contribute, for example, I can take the weight may be 0 to 1. If it highly contribute, I will take 1. The less contribution, 0. The average contribution, I can take 0.5. Below average, 0.25. Above the average, I will take 0.75. According to that, I want to assign the weightages. So, how many parameters I will take? I will assign the weightages. Now, activation function. What is things means? If I have that weight function, everything, so I have that input value, output value, weight also assigned. Then I calculate W1, X1, W2, X2. So this weight, it's maybe calculate either 1 or 0 kind of. So I want to make it this function, it's maybe active nature. I put some kind of activation function. Integral means it's from 0 to 1 it will goes. weight W 1 into X kind of, right? So how this varies from 0 to 1. So these things I put in that loop, it will work. I can get that output. What kind of output I can get? Things means, so these are all the my output. These are all my input. This is the layer. They can develop what is the relationship between BJ to HC, BJ to FC, AST, like kind of. Then again, H to C BJ, HC to FC, HC to AST, HC to BST, like kind of. After that, I can get one optimized results that is called as a joint shear strength tau. That's I can get it. Now, I can get some kind of data. How I can refine it? By pre-processing of the data or post-processing of the data means these are all the some data refinement technique. How I can choose the data. For example, this is I'll take one. The beam column joint means no data I can find. If I can take the 0, no data. For example, I can take the 0.5, I can get some kind of data. So now I can fix this kind of data refinement. I will take some kind of data. Similarly, you can do it. So here I want to train my network with respect to the testing data, training data, and validation data. Training, testing, validation. I take some data. I should train my data. For example, military people, no, they will select some people, they train them for the particular operation. After that, they send the fighter to that army. That is called as a testing data. And validation. Any war will come, all people go and attack the enemy. So similarly, training, testing, and validation is important. Training data, how much I will take, testing data, how much I will take, and all those things, you only decide. For example, 70%, 30%, 20%, 50-50 kind of, you can take it. So using some activation function, you activate this neural network. Finally, you can get the results in terms of coefficient of correlation, root mean square value, SI scatter index. So you can get lot of simultaneous equation. From this equation, you can solve, you can get some kind of values, that value to predict the John shear strength. For example, these are all the weights. Already told you, weights is assigned 0 to 1. Finally, you can get the weight W2. The bias means anything you may be beyond the control, the bias is taking care of, it's maybe tracking to the field. Finally, I can get the equation x1, x2, x4. This is input, W1, W2, W3, W4 and all weight. This is bias. Finally, I can get the function is W1 x1 plus W2 x2. This is activation function. Finally, I got that answer. So this is the some input variables. I can get K1. What is the BJ? Breadth of the joint, height of the joint, FC and all those things. I can develop K1, K2, K3 up to K12. Finally, I can feed all those things in this formula. I can get what is the shear strength of the beam column joint. We consider training data, testing data, and validated data. And previous researcher also did some kind of work. That work also involved here. Finally, I can get that. What is it? Joint shear strength. This formula you can use to calculate what is the shear strength in the particular beam column joint. According that, you can design the structure. The structures may be safe. These are all the some what we call comparison. If you may be asked, why you compare? Yeah. So what is the code? Is our code is have that formula. So through this our code, we can calculate what is the joint shear strength. To calculate the other country code, the joint shear strength, what is the things? These are the things represent here. So these are all the AIJ code. how it's related to, and what is our prediction. For example, here we'll predict now the actual joint shear strength and the predicted joint shear strength using that formula. That coincidence is good only, right? So like this we can develop the model. So what you learn from these presentations today, last 1 hour, means what is mean by beam column joint, what is the need of study of the beam column joint, what is the importance of the beam column joint. This one part we study. After that, what is machine learning, what is deep learning, when you recommend machine learning, when you recommend deep learning. If you come for the machine learning, so what are the things is required? One is a data, learning, output. Data means how can take the data, how to train the data, how to refine the data, and how to assign these things, how these things put in that neural network, how to get that output data. So all those things uh, working in that particular neural network, finally we can get that answer. That answer, it's verified with the previous researchers and the previous predictions. So how much its variation and all we can learn. So through this presentation, we learn these are the things today. So once again, I thank you very much giving an opportunity here to present the AI applications in the field of civil engineering, in particularly prediction of beam column joint strength. Thank you very much, and special thanks to Professor Kumuta.
Thank you, sir.
Is any doubt means you can ask now.
Dear participants, if you have any doubt, you can ask directly. Students. If you have any doubt,
Okay, fine. Thank you. I can assume I did very nice. So no doubt means we can start. Yeah, what are the free open source tools available for civil engineering? Yeah, MATLAB sources available. Some limitations. You can use that kind of softwares. You can develop the simultaneous equation. You can solve. Any other question?
Sir, I have a doubt. Sir,
Yes.
sir, can you hear me?
Yeah. Yes.
yes, Joshua.
Sir. I have
Yes.
a doubt.
Yes, you are audible.
Let's speak.
No audible, sir. Sir, what books will you refer if you want to learn something on machine learning?
What? What he is asking?
He is asking about the books, sir. Books related to.
Books nowadays, our department professor also wrote one book, AI application in civil engineering. That will prepare, and nowadays the not particular specific book available for civil engineering applications. There's a common book only. You read some journal papers, you can get more idea. So that basic introduction about AI, it's available. In particular civil engineering, 1 or 2 books only available. I don't know exactly what is the title of the book, but our Professor Daka, published one book related to applications of AI in civil engineering. Mostly, it takes some time to begin as a textbook. Nowadays, most of the researchers publish the paper in terms of research articles only. I hope I answer your question.
No, sir.
Excuse me, sir.
Yes.
Sir, is there any software to find the concrete strength, sir?
concrete strength, not ready-made software, it's not available. We can develop now using different approach, different algorithms. We can develop. So the lot of constraint is there now for to find the concrete strength. So these are the small example only. So likewise, you can develop some kind of algorithms, then optimization algorithm and all. It may be helpful for your juniors and for you also, but still no standard special software available for predict the concrete strength. So we have the tool, we can develop according to our convenience using the coding. For example, I have the huge data in trace of crore. I can using this kind of algorithm. You feed that data taken from your field. Finally, you can get the what is the strength. That is also possibilities there, but it's our knowledge is still no standard software available. If only feed the all the data, you can get the compression strength. So we have a lot of limitations. This and all things now. That is the problem. Still, I think no, but we can get some results in that AI based results and Google based results also. This and all developed with respect to the previous researchers result only. But you need exact means you develop your own coding, you write equations, you can solve, you can get that good results. Hope I answered your question.
Yes, sir.
Thank you.
Yes, sir. Thank you, sir.
Thank you, sir.
Yeah, thank you.
So that's it. Is there any questions from audience speaking?
Sir,
Yes.
sir, how does machine learning increase safety in construction site, sir? How can we contribute to that?
Yeah, that is good question. That also possible. Application is a plenty in that machine learning. For example, you take this data you go construction industry, you take the data last 20 years, 30 years, 50 years data, what type of construction they done, how many accident what's happened, due to that what is the productivity, and what are the changes happening after that accident, incident, so on, so things. This and all you can develop on data sets. From this you can train the model. Then you can find that what is that problems, and we may be applying that construction industry also. There are possibilities there. This is kind of open kind of technology, open kind of logic only. We can apply this logic in any field. Possibility is there. Some researchers are doing how to predict the possibility accident and what are the causes of the accident also. For example, we are always predicting the future. The why it causes go for the back for re-engineering concept kind of. Then you can find what is the possible accident causes also find. Future also possible, causes also possible. For example, LIC is giving this some insurance people. They're giving money to that claim, that compensation to the particular persons. They will go through that fast record and what are the causes of the accident, what is the nature of accident. According that, they will predict some kind of money, that money given to them. Then applications in the banking sector also. Suppose the students may be approached for the education loan. Nowadays, CIBIL score is directly taken from the database. So basic concepts, this only. So the field, this is the idea is common. You can apply any kind of field, irrespective of civil engineering, mechanical, electrical, automobile, so on. So maybe answer this question.
Yes, sir. Thank you, sir.
Sir, good afternoon, sir. My name is Nagasai, sir. Am I audible, sir?
Yes, now say yes.
Sir, I have one doubt, sir. Can we use AI along with IoT for structural health monitoring, sir?
Sure, definitely we can use. Definitely. You can take what is the basic things need means in the machine learning AI kind of. We need data. We need data. With respect to the data only, it will be function. How to generate the data? Definitely, health monitoring means you can observe or you can take the reading of the stress, strain, deflection, then acceleration, velocity, displacement, so on so parameters with respect to the time. For example, 1 second. What is that? All the parameters. And another second. What is the parameter? Similarly, you can develop the huge data. Then from this data, you can develop one kind of damage model. So you fix the range of, for example, this range of deflection. You can fix the range of vibration, the frequency of vibration with respect to the heads. So similarly, you can add more number of parameters. You fix all those things. You develop one model. Then you can predict what is the health monitoring of the structures. What is IoT means? How transfer the data from field to the data acquisition system or to the computer. That is IoT. That also sometimes you can use this kind of algorithm. So what are the data or unwanted data available in the system? We can develop one coding, one algorithm, put in that loop. So from that source itself, detect unwanted data, only useful data only send to the data acquisition system. So these kind of things we maybe develop, it's good. For example, one more things also, the most of the computer science people doing the research. You take some valuable plant for the medicine. That plant, it's maybe affected by means of some insects, right? So we want to detect or find how much percentage of the plant it's maybe affected by insects. They can find using the deep learning algorithm. Deep learning algorithm. Similar kind of things we can use here, can solve the problem. So, for example, how it means, we'll take the photograph from the site. Each every second, we'll take one photograph. That is called as a tracing sheet. Usually, we'll fix some kind of dotted sheets on the bridge. We'll fix one camera. The camera will capture the image every second or minute. What do the frequency set? Then the camera is captured the image. That image is transferred to the data acquisition system or where we are sitting that particular. That is called as data transmission, right? The IoT's role means how the data transfer from that place to this place. From data capture itself, we can develop some kind of algorithm or some kind of loop. It's reduce that noise or unwanted data, it delete there itself. Only useful data we can send. So how to design this system with respect to the previous experience, which one is good or bad and all the things, we can do it. That is a very good application. You can try also. AI applications in that the linking of IoT and AI possibilities there.
Okay, sir. Thank you, sir.
Yeah, thank you. Any other questions? Yeah, if no question means thank you very much.
Yes, sir. So, on behalf of the Department of Civil Engineering and IIC SPCE, I extend our sincere gratitude to Dr. T.Palanisamy, Associate Professor at NITK, for delivering an insightful and engaging webinar on AI applications in civil engineering. The session provided a valuable understanding on how artificial intelligence and machine learning techniques are applied in civil engineering, particularly in the prediction of material strength and performance. So, thus bringing in theory with practical applications. And I also want to thank Management Principal, Head of the Department, Dr. Kumbuda ma'am, for organizing the session for our students, and IAC convener, Dr. Natarajan, and all other participants for their active involvement during the session, and which made the session a great success. Thank you once again, sir, for your time and presence.
Yeah, thank you very much.
Thank you.
Thank you, sir.